Okay, so let's have a look at another question. Now, this one obviously has a figure as well. It says using figure 1, explain how earthquakes and volcanoes can occur. So they're going to show you an image or a figure, and you have to be able to look at that figure by looking at the way the plates are moving, which way the arrows are showing, and make a judgment and be able to explain the steps of how that works. So let's have a look. So you can see, if you can see, this plate is moving, kind of they're moving towards each other, but one goes underneath. So if you're thinking about a destructive plate boundary, okay, you are correct. So I'm going to go through these in steps again to show you, in a paragraph, once you write these down in these kind of steps in order, you get the full marks. So what would I first of all say? I'll tell the examiner what kind of plate boundary this is. So hold up, yeah, use figure 1, use the earthquakes, talk about the earthquakes and the volcanoes. So figure 1 shows a destructive plate boundary, and we can see here that the two plates are moving towards each other. I would say, again, this is because of the convection currents. Now you have to go into a bit more details in terms of they're not just moving towards each other. Something happens to one of them, which is the oceanic crust over here. Now that oceanic crust subducts underneath the continental crust. Okay, and I would put in the examples there and there, or you could leave it towards the end and tell them an example of one. But again, you would know the one you've studied in class is the Nazca plate subducts underneath the South American plate, and again this forms a subduction zone, as you can see here. Step 3, you go into the kind of question now, the idea of actually how do earthquakes happen. So remember, these two plates, one is subducting. Now once the plate subducts, what happens to this oceanic crust? It gets locked with the continental crust. So we say here earthquakes happen because the two plates lock. Now if you think about it, two plates locking, which will generate enormous amount of kind of pressure to really build up here. Now you could almost imagine, that won't be able to just hold on there locking. Something will happen to those two plates, which is our step 4. Suddenly these plates snap loose. They're releasing lots of pressure, and then you use those kind of keywords saying that it sends shock waves, and which is felt as an earthquake on the surface. Okay, now you can think about actually how do we get the volcanoes now. Okay, so step 5, this plate basically continues to melt, as you can see, and here the upper mantle over here, this heat and energy will kind of almost melt this crust into new magma. So that's the term you want to use. So the oceanic plate continues to subduct, starts to melt, creating new magma. And the last step, what would be actually this magma will eventually do what? The magma, which is lighter than the existing magma that's already there, rises through the cracks in the crust, causing volcanic eruptions. And now you must remember at the end to put down an example, which is the Nazca plate in South America. But again, if you've done it in your step 2, when you're talking about oceanic and continental, then it's fine.